Continuing with our probability series, now we're not just drawing a single card. Instead, we're going to draw 2 cards and see how this little twist changes things. We have 3 problems today. The goal for today is to practice changing the total number of possible outcomes. If you remember from last video, when we were calculating our probabilities, the total number of possible outcomes was always 52. As we will see, that will not be the case today. So let's go over today's method. To tackle today's problems, we will break our problem up into 2 smaller problems and calculate 2 easy probabilities. Then we will multiply our 2 probabilities together to get overall probability. So we're really going to focus on taking a probability question and breaking it up into smaller, simpler chunks. We're going to be using this scary looking formula right here. It looks confusing, so it might be helpful to think about it in plain, simple words first. This formula really says the probability of both A and B occurring is the probability of A multiplied by the probability of B, given that A has already happened. Sounds difficult, but as we solve some problems, you will find it's a lot more intuitive than you may think. So let's get started. Now that we're drawing 2 cards, we have a few different scenarios that can happen. You could either draw 2 red cards, 1 red, 1 black card, or 2 black cards. But we're interested in drawing 2 red cards, so let's define event A as drawing a red card. Let's also define event B as drawing another red card, and here's the important part, given that a red card has already been drawn. So mathematically, we can write it like this, and what this says in words is the probability of drawing 2 red cards is the probability that the first card is red multiplied by the probability that the second card is red, given that a red card has already been drawn. So it's kind of a mouthful, but that's how I want you to say it in your heads. It's really going to help you understand probability. If you get used to this way of thinking, you will comfortably be able to solve many probability problems. So first we ask ourselves the probability of drawing a red card. Hopefully we remember our definition of probability from the last video. There are 52 possible cards and half of them, so 26 of them, are red. This is our first probability. Now what is the probability that the second card is red, given that we know the first card drawn is red? Well, after drawing 1 red card, there are 25 red cards left and 51 possible cards. Why? Remember, it's because we drew a card already and it was red. When a red card is drawn, it is no longer in the deck. This is our second probability, and to find the overall probability, we multiply our individual probabilities, giving a final answer of 26 over 52 times 25 over 51, which simplifies to 25 over 102. Next problem. Once again, we can define our 2 events A and B. Event A is drawing a red card. Event B is drawing a black card, given that we already drew our first red card. And here's the mathematical statement. Again, this says the probability of drawing a red card and then a black card is the probability that the first card is red multiplied by the probability that the second card is black, given that a red card has already been drawn. So at first we have 52 possible cards and 26 red cards, so that probability is still the same as last time. Now when we draw a red card, the number of cards remaining is 51, so this leaves 51 possible cards for the next draw. Last time there are 25 red cards remaining, but since we have not drawn a black card yet, there are still 26 black cards. Make sure you see how and why it is different now. This gives an overall probability of 26 over 52 times 26 over 51, which simplifies to 13 over 51. Now for the final problem, I'm not going to list out each individual event. As you get more practice, you won't need to write this out every time. You'll just go straight to multiplication. So let's get some practice doing this with the final problem. At first, we have 52 cards to choose from and 4 possible 5s. Once we draw a card, there are 51 possible cards left to choose from, but there are still 4 possible 10s. So the overall probability of drawing a 5 at first and then drawing a 10 next is 4 over 52 times 4 over 51, and that's 4 over 663. So extremely unlikely. As you saw today, card problems really start getting trickier when we have to draw more cards. Take a look at some of these crazy probabilities we got today, compared to part 1, which had very simple and nice numbers. And that's the point. Probability won't always give you nice numbers, so don't be afraid to get some nasty looking numbers in the end. As long as you are correctly thinking about successful and possible outcomes and adjusting for any changes to these numbers, your answer will be correct. Now the reason the numbers are changing from 52 to 51 and 26 to 25 is because now the outcome of the first event affects the probability of the second. After drawing one card, we have less total cards. After drawing one red card, we have less red cards. This affects the probability in the end. Now if you think we're going to stop at drawing 2 cards, think again. What comes after 2? That's how many cards we will be drawing next video. I'll see you there.